You collect the energy on one side of the device, where it's then amplified, then polarized. The energy is then integrated into opposite polar semiconductors, where you put a coil around between and on each side of the electromagnetic module and collect the energy. Voila! Free energy.
This is pretty cool. A real-life Dexter's laboratory. Yeah, that's how you say it. A whiz kid with a very powerful idea. Max Laughlin shares his story in tonight's Someone to Know.
The world's smartest kid, Max Laughlin, vanished without a trace after creating an invention that stunned the globe. And now he is back. His disappearance left everyone questioning what could have happened to such a brilliant young mind. What did he discover during his time away? And how does it threaten our understanding of reality? Let's dive into Max's shocking return and the chilling truth he revealed that is causing people around the world to go crazy. Max Laughlin's shocking discovery stuns the world. Max Laughlin, once celebrated as the smartest young person around, shocked everyone by talking about other worlds that might exist alongside ours. Known as a whiz kid from a young age, Max was famous for his bold thoughts on CERN and for coming up with groundbreaking ideas in science and tech, including a new kind of energy that caught the attention of the whole world. He managed to do things that seemed way beyond someone his age, proposing ideas and gadgets that even experienced scientists found almost too hard to pull off. But what Max discovered next, something far more chilling than anyone could imagine, would soon change everything we thought we knew about our world and the ones beyond. Everything about his story took a wild turn when he just disappeared out of nowhere. One day he was here, and the next, it was as if he had just vanished into thin air. Despite the big impact he had left and the many people who tried to find him, it was as if he had never been here at all. His sudden absence led to all kinds of guesses and stories. Some thought he might have hidden himself away to keep his incredible brain safe. Others figured he might be off somewhere no one knew about, doing top-secret research. And a lot of folks thought maybe some powerful group had taken him because they were scared of what he knew. Max was known far and wide as a genius kid who had made some serious contributions to science and tech. So, when he went missing all of a sudden, it wasn't shocking that both the science community and people everywhere were pretty upset. The mess he left behind was full of conspiracy theories and projects that weren't finished, which could have really changed how we live. And just as strangely as he had gone, he popped back up, bringing with him more questions than answers. Right when he came back, Max started sharing some really wild info that was hard for a lot of people to believe. This added even more interest to the already buzzing questions about why he disappeared, what was going on at CERN, and our basic ideas about the universe. Max went beyond just sharing observations. He started giving out warnings, especially about what was happening at the Large Hadron Collider, LHC, at CERN. Even though he was just a kid, Max didn't back down. He made videos to talk about his worries regarding the big organization and what he thought the folks at CERN were up to. These warning videos grabbed the attention of specialists and started conversations worldwide. But what exactly was Max trying to tell everyone about CERN? When he was just 13, Max suggested that the experiments being done with the LHC might actually have the power to open doors to other dimensions, which could be a danger to our own existence. He believed that the super high-energy smashes going on inside the LHC could rip through the fabric that holds our time and space together, potentially linking our world to other, parallel universes without us even knowing. Max argued that these breaks in space could let us peek into different realities, showing us other versions of our own lives and letting us interact with other versions of ourselves. This could totally turn our understanding of space and time upside down, making us question who we are and the reality we live in, and even the possibility of stuff moving between these different universes. The idea of many universes, or a multiverse, is something people have talked about in physics for a long time, and Max thought that the LHC's experiments might be accidentally exploring this idea, maybe even revealing hidden things about the universe. He believed that every time something tiny in the quantum world happens, the universe splits into different paths, creating an endless number of parallel worlds. The smashes happening in the LHC could be small examples of this, connecting us to parallel universes close by. The LHC is a big part of Max's story. He thinks that the tests it runs are actually tearing our universe apart, causing these strange events. He explains that while the experiments start off as planned, Unnoticed mistakes happen that start a chain reaction, splitting reality into countless parallel universes and messing up time, kind of like what happens in the Mandela effect. Just when Max's ideas seemed unbelievable, something even stranger was about to happen, making everyone question their own memories. Our past is being rewritten. The Mandela effect is when a bunch of people remember something from the past differently than how it's recorded in history books or other places. It's named after Nelson Mandela because lots of people oddly remember him dying in prison back in the 80s, long before he actually passed away in 2013. Another example of the Mandela effect is the children's book series, The Berenstain Bears, which some remember as Berenstain Bears. Some even think New Zealand used to be in a different spot on the map. Max uses the Mandela effect to support his theories about other realities and the idea that our past and present might have been changed because of tweaks in time and reality. Max Laughlin remains a figure wrapped in questions and curiosity. His deep insights and serious warnings about the LHC have made him both a fascinating and concerning character. The ideas he shared about the Mandela effect, other dimensions, and the chance of moving between different times and places suggest we might be living in a world that's much more complex than we ever imagined. The Large Hadron Collider, or LHC for short, is known as the largest and most advanced particle accelerator in the world. It's tucked away underground at the border between France and Switzerland, close to Geneva. The idea for the LHC started in the late 1950s, but it wasn't until September 10, 2008, that it actually kicked into gear. This massive piece of technology is part of CERN's complex of accelerators and is expected to be operational for about 20 years. It will take some breaks for upgrades and repairs along the way. What's fascinating is that it can recreate conditions just like those a tiny bit after the Big Bang happened. This giant accelerator smashes tiny high-energy particles together in a very controlled setting, allowing scientists to watch what happens next. Now you might think, so what? Well, it's actually pretty exciting. The framework that this all fits into is the Standard Model, which was put together in the early 1970s. This theory explains the small bits that make up everything and how they interact. It has been great at predicting various scientific phenomena and matches up with pretty much all the experimental data particle physicists have collected. But it's not perfect. It doesn't answer every question we have, like why some of these tiny bits have weight and others don't. Back in the day, 3 smart guys named Robert Brute, Francois Englert, and Peter Higgs came up with a theory. They suggested that there's something they called the Brute-Englert-Higgs mechanism. According to them, there's this invisible field, known as the Higgs field, spread all across the universe. When particles bump into this field, they pick up mass. The more they interact with this field, the heavier they become, and the ones that don't interact much stay light. Scientists have been on the hunt for the Higgs boson, the particle connected to the Higgs field, since the late 1980s. This search was intense and long, but finally, in July 2012, they had a breakthrough at the LHC. They found solid evidence of the Higgs boson, a discovery that has been one of the highlights of using the LHC. People sometimes call this the God particle, because it's so fundamental to our understanding of the universe. Without this particle, nothing would have mass. That means no stars, no planets, and no life as we know it. But discovering this particle isn't where the story ends. Now researchers are digging deeper into the Higgs boson, trying to figure out all its properties and how it behaves in rare situations. At CERN, the place that houses the LHC, physicists are always cooking up new theories to test, making sure they can check them out in real experiments. For example, in January 2022, the folks at CERN shared some news about spotting signs of what they called X particles in this super hot soup made when particles smash together, known as quark-gluon plasma. Theories like supersymmetry or the idea of extra dimensions suggest these X particles might be part of dark matter or something completely new that goes beyond the Standard Model. Every year, the LHC does a special set of experiments where they crash lead ions together to mimic the early universe right after the Big Bang. As Max's thoughts spread, They began to challenge the main ideas in science, leading to tests that could change how we see the world. Is CERN hiding new worlds? These high-speed crashes temporarily create a state known as quark-gluon plasma. Like all scientific experiments, the goal of the LHC is to test out predictions from theories like the Standard Model to find any weak spots. As weird as it might sound, finding these weak spots is actually exciting for physicists because it means there are new things to discover, like dark matter and dark energy. We know about the regular stuff that makes up stars and galaxies. It's only about 4% of the universe. The big question that's been bugging scientists for ages is what makes up the other 96%, with 23% being dark matter and 73% being dark energy. Figuring out dark matter is one of the biggest head-scratchers in physics today. Even though scientists believe dark matter makes up most of the universe, they still aren't sure what it's made of. The LHC, with its powerful ability to smash particles together, is a key tool in trying to detect particles of dark matter. Another huge question in the cosmos is why there's so much more matter than antimatter. According to the Big Bang Theory, the universe started with equal amounts of both. But almost immediately, the antimatter almost completely disappeared, leaving behind the matter that makes up everything we can see. This mismatch is known as CP violation, and figuring it out is one of the main goals of the experiments done at the LHC. These experiments are crucial for understanding not just where we come from, but also the nature of the universe itself. However, there are some concerns about the safety of these experiments. A young guy named Max Laughlin has thrown out some theories suggesting that these experiments could be risky in the future. Even before Max's theories, CERN was no stranger to controversy and alarming predictions since it first started. These concerns grew stronger after they switched on the collider, despite reassurances from CERN that there's nothing to worry about. One of the fears is that the LHC might accidentally create black holes. The idea of missing energy could point to an extra dimension, and one way to possibly see these extra dimensions is by creating microscopic black holes during the experiments. Some people worry that these super small black holes created by high-energy collisions at CERN might end up swallowing the Earth. Recently, there's been talk about a possible quantum black hole appearing near Geneva, which according to some could cause Europe to vanish in an instant, leaving a tiny black hole behind. However, physicists assure us that any black holes created would be very small and short-lived, so they wouldn't be a threat. If these tiny black holes do show up in the LHC's collisions, they would disappear very quickly, in about 10 to the minus 27 seconds. Still, some think that with higher energy levels, creating these black holes might be possible. Only time will tell, as the limits of science and technology are boundless. There's a lot of buzz right now that the Large Hadron Collider might totally mess up Earth's magnetic field. It's a pretty serious concern because the collider uses some super strong magnets to get particles moving super fast. This whole setup eats up a ton of energy, and that's not great for our carbon footprint or the planet. People are really starting to get worried about what this could mean for us. The idea that this collider could change something as critical as the Earth's magnetic field got a bunch of experts to take a closer look at what's going on at CERN, where the collider is. They really dug into the safety measures to see if there's a risk of these high-powered particle smashes causing bigger problems. Even with these fears hanging over them, the folks at CERN are pushing ahead. They're all about making new discoveries, and they're hoping to crack some big scientific questions by the year 2025. They're sticking to their mission of exploring the universe, no matter the challenges. Even with new inventions, Max's work soon brought hope and sparked even bigger debates about what might really be possible in science. Are parallel worlds actually real? And while CERN is staying the course, not everyone's convinced they should. A lot of people are listening to Max Laughlin instead of the seasoned scientists at CERN. You've got to wonder, why are people taking the word of a young kid over these experienced experts? If you're going to be called the smartest young person in the world, you've got to have done something pretty amazing, and Max Laughlin is right up there. He was super smart from a really young age, which set him on a path to do some incredible things. He even stood up to CERN with his ideas, showing he's not afraid to challenge big institutions. Max's love for physics started early, and he was tackling complex ideas when most kids his age were just dealing with basic schoolwork. You might not believe this, But at just 13, Max shook up the scientific community with a device he invented that makes free energy. Imagine a machine that could end our energy worries, providing endless clean power to everyone, everywhere. This could totally change how we live and help the planet at the same time. Max's invention represents a hope for a better future, proving that young minds have the power to bring about massive changes. This free energy machine is just one part of Max's impressive achievements. It's become a symbol of hope and progress, capturing the attention of both scientists and regular folks. Max's work has brought a fresh burst of excitement and optimism, inspiring people to think about what else might be possible. Ever since he introduced his invention, Max has been in the spotlight, gaining fame for his bold theories and deep understanding of the universe. His skills got him into the University of Wisconsin-Madison, where he's diving deep into physics and engineering, aiming to push forward on renewable energy and new scientific breakthroughs. Max's focus isn't just on academics. He's also into practical stuff like modeling ancient artifacts in 3 dimensions, which he did at Valley of Fire State Park. Max's ideas about parallel universes and how our memories might be shared across different realities have sparked a ton of debate. He's even suggested that CERN might be linked to things like the Mandela effect, stirring conversations about what's really possible in our reality. The idea of a multiverse, where each quantum possibility leads to a new universe, has been a mind-bender for scientists and regular folks alike. According to this theory, everything that can happen is happening in some other universe. Quantum physics suggests that particles like electrons can be in many places at once, with each position playing out in its own universe. Physicist Sean Carroll points out that it's not our decisions that create these alternate realities. They happen on their own because of quantum events. It's kind of like how identical twins might start in the same place but end up living totally different lives. Thinking about the multiverse can really change how you see the world. It opens up wild possibilities and makes you wonder about the impact of our choices. But we've got to stay focused on the here and now, where what we do really matters. Max's theories and CERN's experiments are opening new doors in our understanding of everything, urging us to keep exploring and asking big questions. CERN's ongoing work to upgrade their equipment and push the boundaries of what we know is really inspiring. Max Laughlin's ideas are pushing us to think bigger about the universe and what might be out there. His return to the public eye has sparked a lot of excitement about what new things he might discover. Together, Max and CERN are challenging us to rethink what we know about the universe and its hidden depths. Is Max Laughlin's terrifying message just the result of a brilliant mind gone too far? Or did he uncover something far more dangerous that the world isn't ready to face? Could there be a hidden truth that we've all missed? Tell us what you think in the comments, and don't forget to like and subscribe for more.